Okay, we're back. No pictures of Jimi Hendrix at all, even though I love to talk about him. When I was your age, he was one of my heroes. Now, so what we're looking at here is the recoding of this variable called "How religious are you?" And what we did, in effect, was we we created a new binary variable in which we have the 442 people who said they were not at all religious versus the whatever this is, the 1543 people who said they had some religious strength of religion, moderately or very religious. Now, sometimes in t-test we try to have our cell sizes or sample sizes equal. Um, that can sometimes be a problem. But in this class, where we're just trying to get practice with this over and over, we're going to we may deal with that as we go forward. But for right now, you should just observe that we have a lopsided sample, and there are some issues with that. Okay, now let's go use this variable. And before we do that, however, um, let's think about an outcome variable in which we think people who are very religious might differ from those who are not at all religious, or those people who say they're religious to some level versus those who are not at all. Okay, so here we're trying to operationalize this independent variable. Now, I think that the video that I provided before that showed how to do that recoding is something you'll want to practice with, because it could be very useful, because in this class we're only dealing with binary um, independent variables. Okay, so enough of that. Let's jump right into compare means, and we're going to do independent samples t-test. Excuse me. Let's get rid of these. I'm tired of looking at these same old dependent variables. We're certainly going to be looking at a new independent variable. Now you may remember that we recoded these as 0 and 1. So we'll just say this. See, it retains the previous values from the previous analysis, but they're not appropriate now. Okay. And let's see. People who are... Let's go see about... let's look at peer norms. Now, you would have to go back and look at the let's just hold on right here. Okay, so we're talking about peer norms here, and I've just opened up took a break and opened up the survey, and here's the peer norms section, I believe. Now, if we look especially at item number 7 and 8, most of my friends think it's okay to use alcohol and drugs before having sex. I would think that, just from my own personal point of view, you may differ, that people who are highly religious or somewhat religious may have different peer norms than those who are not at all religious. Yeah, I would think that one part of a religion is inculcating kind of normative values in the congregation. So let's go do a t-test on this, and I'm thinking that we need to take a look at what the distribution of peer norms are, and we'll do that next. So let's go back over to SPSS. Before we do this, let's cancel out of here, and let's do an analysis in which we look at the frequency distribution of this peer norms. Let's get rid of this one. Let's come down here. See, peer norms. Peer norms. Now I'm just going to ask for a histogram. It's always a good idea to have a histogram to look at these data. Sometimes we want to put the normal curve on that. That's fine. Say OK. Let's just look at the histogram. Wow, what a nice normal distribution. That we don't see very often, do we? Well, cool. I really don't have any hypothesis about whether people who are highly religious are going to be higher or lower in peer norms. So I'm going to have a two-tailed test, a non-directional hypothesis that just our two groups are going to be different. Okay, I'm just checking it out on this one. Okay, so I want to compare means. I'm going to go to an independent samples t-test. I have to reset these again because I canceled out earlier. I'm going to go to my peer norms. Now I'm going to get rid of academic status. And I'm going to come down here to religious versus not religious. I'm going to define my groups again as 1 and 0. Remember, I could do 0 and 1. It's really just going to change the order of the test in the numerator of the t-test. I'm going to continue. Okay, here we go. Hold on to your hats. Okay, here's what we find. We find that people who hold some stronger religious beliefs have a pure norm of 21, and people who don't have a pure norm of 20. Now you would have to go back and look at those again, so I'm assuming that those higher values are associated with responses that my friends don't think it's okay to drink alcohol and do sex and all kinds of stuff like that. So go back and look at those, back to, I'm assuming that they strongly disagree, and these have been recoded so that high values indicate these that their friends show less what we might call deviant behaviors with regard to their normative values. Okay? Now, what do we see here? Okay, I'm going to ask you this question, and you're in the privacy of your whatever, and you can tell me. Our null hypothesis is that these means are equal. Our alternative hypothesis, because I chickened out, I wasn't sure who would be higher, I said that they would be unequal. That means I have to use the two-tailed test. So I can say, as can be seen in Table 2, those with some religious beliefs show a mean of 21.09, if I rounded that to 2 decimal places, whereas those who show no religious beliefs show a pure norm of 20.19. This difference is statistically significant, comma, t 3.89, parentheses, 1942, close parentheses, comma, p less than 0.001. Okay, now let me do that again, and then we'll stop this. I can say, as can be seen in Table 2 or Figure 3 or whatever it is, those who hold strong to moderate religious beliefs show pure norms of 21.09 versus those who show no religious belief, report no religious beliefs of 20.19. This, as tested by an independent samples t-test, this difference was significant, comma, t, parentheses, 19.42, parentheses, p less than 0.001. Okay, does that make sense? Did I do that right? So I'm going to say this shows there's no significant differences, comma, t 1942, parentheses, parentheses, equals 3.89. I realized I did it wrong a minute ago. So we should say no significant differences, comma, t, parentheses, 1942, close parentheses, equals 3.89, comma, p less than 0.01. Okay, let's stop there.